For today, we're going to actually put that to use. Instead of just setting it up, we're going to use those trig functions to help us find missing sides. If you recall from last week, we did the Pythagorean theorem. The Pythagorean theorem works when we have 2 out of the 3 sides in a triangle. Trigonometry is going to work with only 1 side. To find missing sides, you need, at minimum, 1 side and 1 angle. Okay, you're going to see that we have this in all of our triangles that we're going to see today. You will have an angle measure, you will have a side measure, and then you'll have another side that is like an X, which is what we're trying to find. I'm going to write at the top of our page our SOHCAHTOA just so that we all have it and we can see it right at the top of our page. SOHCAHTOA. Okay, I'm going to do 1, and then I'm hoping that you're going to catch on and we'll see the patterns here. So when I take a look at my right triangle here, the first thing that I need to do is look at the angle. If you remember from Friday, the most important thing that we do is make sure everything is going back to the same angle. So in this triangle, I have a side that I know and a side that I'm trying to find. The side that we know here is my hypotenuse side. It's the 23. It's across from the right angle. And the side that I want to know is across from the 56 degrees. That makes it the opposite. So if I have an opposite and a hypotenuse, then the trig function that I'm going to use, I look at my acronym, SOHCAHTOA, the one that uses opposite and hypotenuse is sine. It's the SO. So I'm going to start this problem by writing the abbreviation for my trig function sine. Immediately next to where I write sine, I need to write the angle measure. So this angle measure is 56, so this now says sine 56. I'm going to put an equal sign after that. And then I'm going to write the fraction of my trig function, which again, let's look. So O comes first, H comes second, so I know that I want the O on the top and the H on the bottom. The opposite is X, and the hypotenuse is 23. Any questions on that setup? Okay. The rest of the problem is just going to be algebra. We are solving for that value X. So I'm going to do way back in the beginning of the year, we put a line down the middle, and we're trying to get that X by itself. X is currently divided by 3, so the opposite of divided by 23, the opposite of dividing by 23 is multiply by 23. When we multiply something to a trig function, it's just going to go right out here in the front. It does not multiply to that number, it just goes right in the front. So this says 23 times sine 56. Any questions on that algebra step? Do we see that X is now alone? That's what we're going to now plug into my calculator. 23 sine 56. I'm going to go to my calculator and I will type in 23, just like that, sine 56. Just like that, all in one line. I'm going to hit enter. Hopefully you get 19.1. If you did not get 19.1, let me know now. Everybody good? Everybody got it? So that's my answer. 19.1 equals X. So this side length right here is 19.1 units. Everybody good? You think you can help me out a little bit with the next one? So I'm going to look at B. I'm going to focus on this angle 38. What 2 pieces do I have / need to find? Opposite, adjacent, hypotenuse. What are those pieces? I need to find the opposite, and I already have the adjacent. So O and A, which means which trig function am I using if I have O and A? Tangent, TOA. So I'm going to start with the name of the trig function, tangent. What comes right after I write tangent? 38, the degrees. And then equals, and this part matters. We got to make sure we set this up in the right order. What over what? X over 18. Opposite over adjacent. Perfect. Any questions on that setup? You need to have this step written down for sure. Then I solve. How do I solve for that X? Times 18 on both sides. So this is 18 tangent 38 equals X. X is now by itself, so that's what's going to go into my calculator. 18 tangent 38. So let's calculate it. 18 tangent 38. I get 14.1. Everybody good with that? Let's do one more like this, and then we'll move on to the back side. So let's do letter C. I'm going to start with my angle. I need to identify what pieces do I have here. What pieces of my triangle? Hypotenuse. Good, because it's across from the right angle. What about the other side? The adjacent, because it's right next to that angle. Great. So with that, what trig function am I using? Cosine is A and H. It's the Oops. Cosine. What goes right after cosine? 24, the angle. And then my fraction, what does that look like? Perfect. Adjacent over hypotenuse. It is not. I'm going to show you on the next page. Okay, so then how do I solve this? So I'm going to rewrite this as 9.5 cosine 24 equals X. And that's what I'm putting into my calculator. 9.5 cosine 24. I got 8.7. All good. Any questions there? Flip it over. We're not going to do the fourth one. I'm actually going to skip the next three also. I'm going to go straight to letter D. I'm going to come back to those next three probably for warm-up tomorrow. So just leave them. Okay, let's look at letter D. I'm going to start the same way. I'm looking at my angle. What two pieces do I have in this problem? The opposite all the way across and the hypotenuse across from the right angle. So which trig function is that? Yep, so I'm going to let me write SOHCAHTOA out here again. So O and H is sine. Right after the sine, I write 65, the angle. And then what does the fraction look like here? 10 over x, opposite over hypotenuse. Okay, so this happens sometimes. It's actually going to happen probably like 50% of the time. So we need to make sure that we know how to solve this. How do I solve this? Can I multiply by 10 to get rid of that 10? No. We have a very, very strict rule that says the numerator here is stuck. That means I cannot move it. Only the denominator can move. I can't do anything with the sine 65. I can't do anything with the 10. The only thing that can move here is the x. So we're going to move it. We got to be a little bit tricky here to solve this. I'm going to rewrite this as x times sine 65, just like I did with the numbers, right? The numbers went in the front, the x goes in the front. So this is now x times sine 65 equals 10. Is x isolated? Can I be done yet? No. So how do I isolate x now? Now I need to divide by sine 65. Sine 65 is like one big number, okay? I can't separate them. They go together. I can't have a sine or a cosine or a tangent without the number next to it. So I'm going to divide this by sine 65. So now it goes away on the left side, and I have x equals 10 divided by sine 65. That's it for this one. Now that x is isolated, now I can go ahead and plug it back into my calculator. So I'm going to plug it into my calculator exactly like that as 10 divided by sine 65. Everybody see that? Hit enter. I got 11.0, we'll call it. Oops. Does everybody understand the difference between this and the previous problems? Because that x is on the bottom, we have a little bit of weird trickery we got to do. Okay, let's look at a couple more. Letter E. What are we thinking? What pieces do we have here? What pieces of my puzzle do I have? Okay, good. So that means which trig function? Cosine. The angle goes after the cosine, so cosine 62. And then how am I writing this fraction? Beautiful. Now I need to solve. How do I start to solve this? Multiply by x on each side. That 16 is trapped. It cannot move. So this is now x times cosine 62 equals 16. Am I done? How do I solve? So this is x equals 16 over cosine 62. And I can plug it into my calculator with that division. 16 divided by cosine 62. About 34.1. Does that sound about right? Okay, one more. And then the word problems. Set this up for me. What does it look like? Anybody want to give it a go? Go ahead, Cody. Okay. Tangent 38. I like it. Then what? Good. Oops. Solve. Then? So x equals 11 divided by tangent 38. That's what's going into my calculator. 11 divided by tangent 38, about 14.1. Any questions on that? Okay. I really like these problems. They're a little bit tricky, though. We do not have the triangle. I know I need to draw what kind of triangle, though. It has to be a right triangle. If you are not drawing a right triangle, you're already off to a bad start. So I'm going to draw a triangle, and I'm going to put a right angle in it. This one says the hypotenuse is 13 inches long. I know the hypotenuse. It has to go in the same place in every right triangle. That's got to go across from my right angle. But then it says, how long is the side opposite a 50-degree angle? Do we know which one the 50-degree angle is? Not really, but I'm making this triangle up as I go. So I'm going to put the 50-degree angle wherever I want to put the 50-degree angle. Then the side opposite that 50-degree angle would end up over here. Which trig function am I using here? Sine. I've got hypotenuse, I've got opposite. So this is sine. What's my angle? Equals. Beautiful. How do I solve this? Beautiful. When I multiply that 13 over to the other side, I'm done. My x is already isolated. So a little bit of an easier problem. I do 13 sine 50, and I'm going to end up with about 10 when I round that to one decimal place. Oh, what's our unit, though? Do we have a unit in this problem? Inches. Beautiful. Okay. All right, one more. I've got a right triangle. You better start with a right triangle or you're off to a bad start. The adjacent side is 15 centimeters. How long is the side opposite a 35-degree angle? Where do I want to start here? Sure. That 35-degree angle, we're making this triangle up. It can go anywhere. Let's put it in the top. Then it says the adjacent side is 15 centimeters long. Where's the adjacent side? Left, right, or bottom? It's going to go on the left. Here is the adjacent. I cannot put that adjacent side on the right side because that would be the hypotenuse. This is hypotenuse. Then it says the side opposite that is opposite the 35 degree is what we're trying to find. So that's what I'm going to make the x. Which trig function are we using here? So I have tangent, my angle 35 equals, what's my fraction? Perfect. And then we solve. We're going to multiply by 15 on both sides. 15 tangent 35 equals x. We can plug that into our calculator. 15 tangent 35. Nope. 15 tangent 35. 10.5? Good. And I believe we have centimeters this time. All right, any questions on that?